Hey everyone, my name is Mrs. Kelm and I am one of the algebra teachers at the high school. You are going to be watching videos that I create to take you through some of the material as an introduction to new concepts that expand what you were already learning in the classroom. Because these are videos, I encourage you to use the pause and rewind features to go ahead and look at questions again and make sure you understand before moving on. I will also encourage you to pause at points within the video and try things on your own so you can then look at what I have done to ensure that you understand before trying to complete problems all on your own. In case you have any questions specifically about the videos, I'm including my email address here so that you can ask me questions in addition to your own teachers. We're all here to help you get through this challenging time. Do not hesitate to reach out with any concerns that you might have. Now let's go ahead and try to look at the review material for quadratic equations.
Okay, welcome to video 8 here. Today we're going to be talking about quadratic application problems. So we're going to take the same things that we've already learned and now we're going to apply them to real life questions. So a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by, and then we have this function. H of t equals negative 16t squared plus 64t plus 80, where t is time in seconds and h is the height in feet.
So the first question is, what is the initial height of the rocket? Well, if we're talking about the initial height, that means that it's before any time has passed. So knowing this initial height part, that tells me that I can write t equals 0. So if I know what the t value is, because no time has passed, then I can go ahead and put the 0 in place of t. So before I write down the answer, go ahead and try substituting in the 0 for t and finding out what that initial height is. So I encourage you to pause the video and give that a try before checking with what I wrote. So the first line I just wrote h of 0 equals, and then everywhere I had a t in my original equation, I plugged in that 0. So when I put this all in my calculator exactly the way I see it with parentheses, I'll end up with h of 0 equal to 80. So that tells me that my initial height is 80 feet. Now the next question says, how long will it take for the rocket to reach 128 feet? So we always have to think, okay, what are they giving us? Is it an input or an output? So I know the height is 128 feet. So that means instead of being h of t equals, the 128 will go in place of the h of t. So 128 equals negative 16 t squared plus 64t plus 80. Okay, now we have a quadratic here. So think to yourself, what are my options to solve a quadratic? Well, the options are to use factoring, completing the square, or quadratic formula. In this example, I'm going to go ahead and use factoring. So in order to factor, I need it to be equal to 0. And although it's more work to move everything from the right side to the left, I'm going to do that because then I have an a term that's positive 16 instead of the negative. Now, it wouldn't be wrong to subtract 128 to the other side, but then we would have a negative a value, and sometimes kids make mistakes by losing that negative value. So instead, I'm going to move all three of these to the other side. Now that I have this in standard form, I can choose an option to solve. I'm going to use factoring. Now, depending on your teacher, your factoring may look a little different because I use boxes to factor. So first thing I do is put the 16t squared minus 64t and the plus 48 in a box to see if I can find a GCF that comes out. The GCF amongst these three terms is 16, so I can pull a 16 into this place and then figure out what would need to go up here to multiply to 16t squared, or think of it as dividing 16t squared by 16. So that would mean we would need a t squared up here. And then when we look at negative 64t divided by 16, or what times 16 is negative 64t, that's a negative 4t. And then in the last spot, what times 16 is 48, or 48 divided by 16, that's positive 3. Then I can write it as these two factors, so 16 times the t squared minus 4t plus 3, and I'm going to write it over here. So the two factors are 16 and then the t squared minus 4t plus 3, still equal to 0. And then we'll go ahead and factor the inside the t squared minus 4t plus 3. Now to factor this, since it's a trinomial, I'm going to set up the x and a box. Then I need to identify what a, b, and c are in order to fill in the x diagram. A is 1, B is negative 4, and C is 3. So then A times C goes in the top and B goes in the bottom of my x. So I need to find two numbers that have a product of 3, or multiply to be 3, and have a sum of negative 4, or add up to negative 4. Now pause and take a minute to try to figure out those numbers on your own. The answer is negative 3 and negative 1. So now I can rewrite that middle term, the negative 4t, to be those two numbers, the negative 3 and the negative 1. Now that I have it set up this way, I'm ready for factor by grouping. Now again, this might look a little different depending on your teacher and how you learn to factor. So I'm going to take the first two and fill in the top row of my box, and the second two to fill in the bottom. With the t squared minus 3t in this top, I need to find what the greatest common factor is to factor out to fill in this first spot here. So the GCF here would be a t. Then we work to figure out what would need to go in the other spot to complete this to be t squared. So what times t is t squared? That would mean a t would go up here because t times t will give me t squared. And then a negative 3 would need to go here because that will make negative 3 times t give me the negative 3t that I need for this box. And then in the last spot, what times t would give me a negative 1t? That would be a negative 1 here. And then always remember to check the last one. Negative 1 times negative 3 is a positive 3, so I'm confident in my answer. So these are the two factors then, t minus 3 and t minus 1. Okay, so now that I've done this, I have my factors and nothing can be factored any further. I can go ahead and set up my chart to figure out what the factors would need to be, the values of t would be, to make the product 0. So this is the point where I reject the 16 as an answer because I can't make 16 equal 0. It just isn't true. Your teacher may have also eliminated this 16 back at the beginning by dividing both sides by 16. So if you don't have the 16 coming along for the ride, that might have been what your teacher taught you. I just like to bring the 16 down all the way because when we factor, we don't want to lose our GCF. So I ignore the 0 until I've gotten to this point and then decide to look at, okay, well, now I'm not just factoring. This is the 16 times t squared minus 64t plus 48 factored, but then it equals 0, so that's where I put in the equals 0 and eliminate the 16 as an answer. So then I can look at t minus 3 equals 0. I can make that equal 0 by adding 3 to both sides. And then I would get an answer of t equals 3. And then for the other one, t minus 1 equals 0. I can add 1 to both sides to solve for t. And then I get t equals 1 as my second answer. Now, these are both good answers because there are no negatives in here, so I don't need to reject any of these two answers because I can have a time value of 3 and I can have a time value of 1. So my answer then with a label would be the rocket would reach 128 feet at 1 second and then again at 3 seconds. So those are the two answers, and that's the answer with a label. I always like to put labels on the answer so that I can think to myself, okay, well, does my answer make sense? Does it make sense that it would hit that height at 1 second and 3 seconds? Okay, the next question says that the area of a rectangular playground enclosure at Happy Times Nursery School is 600 square meters. The length is 25 meters longer than the width. We need to find the dimensions of the playground. So to start off, I'm going to highlight my important information in the question. I encourage you to pause and highlight what you think is most important as well. So I know I'm talking about area of a rectangular playground, 600 square meters. The length is 25 meters longer than the width, and I need to find the dimensions. So I'm going to start by drawing a picture to represent the rectangular playground. Then I know I'm talking about area, so I'm going to write the formula for area. So my area equals length times the width. So I know that the area is 600 meters squared. So I just like to put that inside of the box. And then I know the length is 25 meters longer than the width. I don't know anything about the width, so on the width of my diagram, I'm going to put an X to represent that I don't know what it is. And on the length, since it's 25 meters longer than the width, I'm going to put X plus 25. Okay, now pause for a minute and see if you can fill in the information into the area formula. So we'll have an equation we can use to solve for the dimensions. So I have 600 because that's what the area is. So I plugged in the 600 in place of A. And then I wrote it as x times x plus 25. You might have written it as x plus 25 times x. It doesn't matter either way. I just like to put the monomial before the binomial. Okay, so now I can see here that I need to distribute this x to both things in the parentheses so that I can simplify and have a degree of 2. So I can see that it's a quadratic I need to solve. The reason I know I need to do that is because I don't have any other way to solve when I have these two x's over here. I have to get them together so that I can solve for x. Now that I have an x squared with a 25x, I know it's a quadratic, so I need to solve by moving the 600 to the other side so that I can solve for the zeros, because the equation will be in standard form. Then I'll end up with 0 on the left-hand side. And on the right-hand side, since there are no like terms, I just have to write this out as the x squared plus 25x minus the 600. Now that I've done this, I can think to myself, okay, how can I solve a quadratic? Well, there are three options. One is to factor, like we did up above. The other is to use completing the square. And the third is to use the quadratic formula. So in this example, I'm going to model using the quadratic formula. So first thing that I need to do is check for standard form. It is in standard form. Then I need to identify the A, B, and C value so that I can substitute them into the quadratic formula. The A value is 1, the B value is 25, and the C value is negative 600. Now, if you need the quadratic formula, remember that you have a formula sheet that has the quadratic formula on it. In case you need a refresher of the formula, here it is over here. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. Then we can go ahead, now that I've identified these three, substitute them in for a, b, and c. So pause and see if you sub them in the same way I do. So when I substitute them into the formula, I get x equals negative and then the 25. Remember to use parentheses whenever we substitute in, and then plus minus radical, and underneath the radical I have parentheses 25 close parentheses squared minus 4 parentheses 1 close parentheses negative 600 close parentheses all over 2 parentheses 1 close parentheses. Now remember, the parentheses are helpful so that we can make sure that we don't lose a negative or square a number and then make it negative instead of squaring a negative number. The next step is to simplify. So out in front here, the negative 25 becomes negative 25. Next, remember to put everything under the radical, but not the radical yet, just all the information that's underneath it in your calculator to simplify what the number under the radical should be. Take a minute to try that and see if your number matches mine. The number that I got is 3,025. So a couple things to remember here. We have the 3,025 still under the radical, and then out front we have a plus minus, accounting for that this number can be positive or negative. All divided by, and then 2 times 1 is 2. Now we can try the number under the radical, placing it in our calculator with the square root this time to see if it's a perfect square. Well, the square root of 3,025 is 55, so we can change that to be negative 25 plus minus 55 divided by 2. Now remember, since it is the plus minus 55, I have two different answers. So we can split this off to the side. You can either go to the right or down below, but this separates into two answers. 25 plus 55 divided by 2, x also equals negative 25 minus 55 divided by 2. So in your calculator, you can either put this in as a fraction or simplify the top and then divide by the denominator since the denominator is already simplified. So negative 25 plus 55 is 30, and then 30 divided by 2 is 15. And then our other answer, negative 25 minus 55 is negative 80. Negative 80 divided by 2 is negative 40. Now, before we even think about rejecting any answers, you need to remember that these are in the context of a problem. So we just solved for something. What did we solve for? We solved for x, or the width of the playground. So now if I think about it, can a width be 15? Yes, it can be 15 meters long. Can a width be negative 40? No, because we can't have a negative width. So over here I'm going to reject this, but I always write down why I'm rejecting it. So to the side, I just wrote reject negative width. Can't have a negative width. So now what did I solve for? I solved for x. So up here, I can change this x to equal 15. And in this one, I can change it to 15 plus 25. So in my diagram, I can see that x is 15 and the length there is 40. So off to the side now, I'm just going to write my final answer. The length of the rectangular playground is 40 meters and the width is 15 meters. Now your task is to answer the next 3 questions. And remember, if you have any questions, you can reach out and let us know. Thank you. Have a good day.